Okay, let's take a closer look at oxidoreduction. Oxidoreduction reactions. The chemical definition of oxidoreduction is that oxidation is the removal of electrons from an atom or a molecule, and reduction is the gain of electrons. Electrons are not lost. If an atom or molecule loses electrons, another must gain these electrons. Following electrons may be simple in chemistry. In biology, we'll deal with large molecules, and the transfer of electrons is not obvious. So here is the modified definition of oxidoreduction that is used in biology. Oxidation is the loss of electrons and hydrogen atoms from a donor molecule. So here we add hydrogens. The acceptor molecule right here accepts electrons and hydrogens. Slide 3 right here is a summary of the different forms of oxidations that can be seen in biology, either gain in valence or loss of electrons, right here, or addition of oxygen, right here, or loss of hydrogens, right here. We will see oxidation chapter 6 when we study cell respiration. In cellular respiration, a highly reduced molecule, glucose, loses electrons and is oxidized to CO2. Notice that glucose, right here, lost electrons as well as hydrogens. It is easy to see that hydrogens were lost. This right here is the carbon dioxide. If electrons and hydrogens are lost from glucose, they must have gone somewhere. Oxygen is the electron acceptor, and water is produced. This is the formula for respiration. So now for some vocabulary. NAD, in this case, is an oxidant. That means that it is an electron acceptor and will gain electrons. H2, where A is any random molecule, is a reducing agent. That means that it is an electron donor and will lose electrons. Now the question is electrons. What electrons? We don't see a movement of electrons right here. But it is easy to follow the fate of hydrogens. If NADH acquired electrons right here, it is an electron acceptor. It accepted hydrogens in this reaction. AH2 is a reducing agent. It is an electron donor and lost hydrogens in the process. So right here we have the electron acceptor. This is an acceptor because it can accept electrons. This is the donor because it lost hydrogens and electrons. On slide 9, we can apply this concept to cellular respiration. Glucose is oxidized to CO2. It loses hydrogens. Oxygen is reduced to water. It accepted hydrogens. The opposite reaction is what happens in photosynthesis. Here, CO2 is reduced to glucose, and water is split. It releases electrons, and it's released as oxygen gas. Now let's look at this equation. Oxidoreduction, the final step of aerobic respiration. Water accepts oxygen accepts hydrogens and is reduced to water. So which compound is reduced? It is easy to see. The answer, it's oxygen. This is another example of a redox reaction, but it's a little bit more complicated. In this reaction, which compound is oxidized, which compound is reduced? First of all, lactate right here and NAD are neither oxidized nor reduced in this reaction. They are end products. So let's cross them out. Only the reactants, pyruvate and NADH plus H plus, can be either oxidized or reduced. Now let's decide which one is oxidized. We apply the definition. We look for loss of hydrogen, which is oxidation. NADH loses hydrogen in this reaction. Therefore, it is oxidized. Pyruvate gained hydrogens in the process. It is reduced. This is the last step in fermentation. In mussels, this is what happens when there isn't enough oxygen to perform cellular respiration. Only anaerobic processes take place, and this is the last step, with lactate being produced. Indeed, only pyruvate and NADH are possible answers. Pyruvate is reduced to lactate, NADH is oxidized to NAD+. Lactate and NAD+ are just products. In the end, common electron carriers. Some coenzymes serve as the most common electron carriers, and they shuttle electrons back and forth. We will learn more about them when we study respiration and photosynthesis. Electron carriers are derived from vitamins, which explain why vitamins are so important in the diet. Energy metabolism depends on those vitamins being available to the cell. So right here we have NAD, which is derived from niacin, NADP, which is also derived from niacin, and FAD, which is derived from riboflavin. Here you have the common terminology for vitamins, vitamin B3, vitamin B2. And this concludes my presentation. Thank you for listening.